Let's peel back the cover on the tools and tech that shape our world. Ready for a deep dive? This channel is your backstage pass into the fascinating universe of big machines, smart products, and next-level tools. We break down the mechanics behind everything from industrial robots and circuit boards to power tools and DIY repairs. Curious about how things work, how they're made, or even how to fix them. Have you ever wondered how we can see things that are completely invisible? I'm not talking about ghosts or mythical creatures. I'm talking about electricity, sound, radio waves. These forces are all around us every single second of every day. They power our homes, carry our conversations, fill our rooms with music, but you can't see them with your naked eye. So how do we know they're there? How do we measure them and make sure they're doing what they're supposed to do? We need a special kind of eyeball for this job. A tool that can translate this invisible world into something we can finally see. That's where the oscilloscope comes in. It's one of my absolute favorite tools in the workshop. In the simplest terms, an oscilloscope is a type of electronic test instrument. It allows you to observe varying signal voltages. Think of it as a super-powered voltmeter with a screen. A regular voltmeter gives you a number, but an oscilloscope gives you a picture. Let's break this amazing tool down. Looking at an oscilloscope can be intimidating. There are so many knobs and buttons, but don't worry, they all serve a purpose, and the main controls are actually quite simple once you know what they do. The most important part is the screen, or the display. This is where the magic happens. The screen has a grid on it called the graticule. This grid isn't just for looks, it's a ruler that lets you measure the characteristics of the wave, like its height and its width, which tell you about voltage and time. Then you have the controls, which are usually grouped into a few main sections. The most important are the vertical and horizontal controls. The vertical controls are all about the y-axis, or the up and down part of the wave. The main knob here is the volts div, volts per division. This knob is like a zoom lens for the signal strength or amplitude. Turning it lets you make the wave appear taller or shorter on the screen, fitting it perfectly within the grid so you can measure its voltage. It's how you scale the signal to a readable size. So, what do these waves actually look like? The amazing part is that different signals create different shapes, each telling a unique story. Let's think about sound. If you were to play a single pure note from a flute and hook it up to an oscilloscope, you'd see a beautiful, smooth, rolling wave. This is a Cine wave, the simplest and most fundamental waveform in nature. It's clean, elegant, and perfectly uniform. It's the building block of so many other more complex signals that we see and interact with every single day in the world around us. Now let's switch from music to medicine. If you connect an oscilloscope to an EKG machine measuring a human heartbeat, you see something totally different. You get that iconic blip, blip, blip pattern. It's a sharp spike followed by a little dip, and then a smaller bump. That shape is called the QRS complex, and doctors can read it like a book. What about something more complex, like a piece of hard rock music? It's not a single pure note, it's a chaotic mix of drums, distorted guitars, bass vocals. On an oscilloscope, this looks like a wild, jagged, and dense mess of lines. Here's a fun fact that might surprise you. The core technology behind the original oscilloscopes helped give birth to television. The old cathode ray tube TVs, those big heavy boxes, worked on a very similar principle. An electron beam was fired at a phosphorescent screen, and magnetic fields would steer the beam left and right, up and down, drawing the picture line by line, just like an oscilloscope draws a waveform. Now think about your smartphone. It doesn't have a big CRT inside, but it's absolutely packed with components that were designed, tested, and perfected using oscilloscopes. Wi-Fi cellular radios engineers used oscilloscopes to make sure those high-frequency signals were clean and strong. The processor that runs all your apps? It relies on perfect clockwork-like digital signals, square waves, that were verified on an oscilloscope screen. Even the sensor that flips your screen when you turn your phone sideways was likely developed with one. Today, you can get small, portable, and even USB-powered oscilloscopes that are affordable for anyone with a curious mind. It's a tool that empowers you to not just use technology, but to understand it, to question it, and maybe even to fix it or build it yourself. The world is full of them, just waiting to be seen.